Hello everyone, welcome to week 17 of Geometry Standard. This week we're going to be working on 10.8 and we're going to be talking about volume and surface area again. This time it's going to be with spheres. Okay. Our learning target is I can find the volume and surface area of a sphere. So hopefully you guys know how to use pyramids, you know how to find this prisms, cones, cylinders. Now we're going to work with a sphere. And when you think of a sphere, it's kind of like a ball. It is a ball. Okay? And since a ball is kind of similar to a circle, we are going to have to use those pi formulas. So let's just go ahead and jump in and learn our new formulas. Okay? So on a surface area of a sphere, there's two ways we can look at this. There is S equals, so my surface area equals 4 times pi r squared. Now hopefully this pi r squared should be super familiar to you guys. That is going to be the area of a circle. Okay. When we write this in terms of just the area, it would be S equals 4 times A. Okay, and A is going to be the area of the great circle. And we're going to talk about that in a little bit. And of course that R, remember that's just our radius. Our radius goes from the center of our sphere to the outside. And that would be in the great circle. Okay. And then let's talk about the volume of a sphere. Remember, volume is what it's going to take to fill it up. The volume of a sphere with radius r is going to be V equals, okay, instead of 4 this time, we're going to use 4 over 3. So 4 divided by 3. And then we're going to multiply that by pi and multiply it by r cubed. Okay, remember we do use cubed when we're working with volume. Okay. And if we want to talk about our units, if we're using surface area, it will be units squared. And if we're doing volume, your answer is going to have units cubed. Okay, hopefully you guys should be used to that part by now. So I say let's go ahead and take these formulas and jump right into some examples. So the first problem is find the volume and surface area of the sphere. Round your answer to the nearest tenth. So we're going to have to work with both of these formulas. So the first thing I'm going to do with our problem is I'm going to write out those formulas. So I have my surface area is that 4 pi r squared, or 4 times the area. Since I'm not given the area, I can go ahead and work with this one. And then my volume is going to be 4/3 pi r cubed. Okay. And in both of these, the only variable we need is my radius. Well, that's kind of nice because I have my radius. It's right here. So remember, radius goes from the center of our sphere, okay, and it's going to go out to one of the edges. It could be anywhere in the circle or in the sphere, okay, but it has to go from the center out. Okay. If I have my r is 9, so we're going to go ahead and substitute that in. So now I have, 4 pi 9 squared. Okay, and of course order of operations tells me I should do 9 squared first, which is going to give me 81. I'll then do 81 times 4, which is going to give me 324. And remember, I didn't type that pi in. So if I wanted my answer in terms of pi, I would be done here. I just have to write my units. In our case, we want to take it another step forward. So we're going to go ahead and type 324 times our pi, or you could just put that pi button. Remember, if you don't have a pi button, which you should if you're using your wonderful Desmos calculator, you can go ahead and use 3.14 instead. Okay, so I have 1017.87. And because I was asked to round to the 10th, okay, I like to go one space past, okay, and I know my 10th is this 8 place, and then I look at the 7. 7 tells me to bump it up because it is 5 or bigger. Okay, so when I write this one, I'm going to keep all of my first numbers the same, and then my underlined number is going to be bumped up. And in this case, remember, it's surface area, so my units is going to be squared, and my unit is centimeters. Okay, so that's one of my answers. I can go ahead and write that in the blank. Okay. And now let's go ahead and work with the volume. Okay. Again, the only variable we're working with is that radius. Okay. So I have 4/3 pi, and remember my r was that 9. So 9 cubed. Okay, now be super careful as you type this one in. Make sure you have to the 3rd power. Make sure you're not accidentally hitting that 2nd power. Okay. If you don't have a exponent button, you can go ahead and do 9 times 9 times 9, okay, or whatever the number is, times itself by 3, or 3 times, sorry. Okay, let's go ahead and do that to get 729. Now we want to be super careful as we type this part in. Okay, we have 4/3, so you can use that as a fraction. Make sure you're typing it in carefully. You might have to put it in parentheses. If you're using your Desmos calculator, it should look exactly like this. Okay, or we can take 729, times it by our top number, which is 4, and then take that number and divide it by our 3. Okay. So if I times it, if I did 729 times 4, I got 2,916, and I still need to divide it by 3. When I went ahead and did that, I got 972. I still did not use my pi button. Okay. So then my last step is to go ahead and multiply 972 by the pi, use your pi button, or 3.14. I got 3,053.62. Round to the nearest 10th. I'm looking at my 6. My 2 tells me to stay. Okay. So my volume is going to be 3,053.6. Again, I'm working with centimeters, and since it is volume, it will be cubed. And go ahead and make sure the answer is also in your volume blank. That way we know we are getting full points. For this next problem, let's move just a little bit faster because it does have more to it. So the first thing you should notice is, hey, this is not a full sphere. This is only half a sphere. So we do have to follow some different steps. Okay. So when we have a half of a sphere, we're going to work with our two formulas. So surface area is going to be 4 pi r squared. Okay. But in this case, surface area is going to be talking about all of the outside of a full sphere. So if I were to highlight all of the outside of it, okay, that's the full sphere. I only want half of that. So I'm going to take this part of the formula and divide it by 2. Okay. Well, then I also need to account for the part at the bottom that is covering up where we cut. Otherwise, it would just be like if you cut open a soccer ball and there was nothing inside the soccer ball except for air. Okay, we want that fabric there or over the top, so it's half of that sphere. Okay, so to account for this, we also need to add the area of that circle. Well, we know the area of a circle, and it's pi r squared. So we do have some extra steps to do for this one, okay? Again, looking at this, the only variable is going to be our r. So if we know our r is 4 meters, we can go ahead and solve this. Okay, let's go ahead and substitute this for n. So I have 4 pi times 4 squared divided by 2 plus pi 4 squared. Okay, well, I know 4 squared is 16, so I'm going to go ahead and write 16 in for both of those, both of the 4 squared. Okay, and then I can go ahead and solve this first fraction. Remember, we need to take care of this first part and the second part before we can add them. If we are using our Desmos calculator, we can go ahead and type this in, making sure you are super careful that you're keeping all of the order of operations and typing it in exactly as you wrote it. If I went ahead and did my 4 times 16 divided by 2, I would have 32 pi plus this 16 pi. I'm just going to go ahead and move that 16 out front, and then I can add those to get 48 pi. Okay, this is my answer in terms of pi. I want to take it one step further and make sure I am rounding it to the nearest 10. And I got 150.79. Going ahead to look at that 7, my 9 tells me to bump it up. So when I rewrite my surface area, I have 150.8. I am working with meters, and this will be surface area, so it's squared. When we're working with volume and our half of a sphere, it works a little bit differently, okay? And it's a good different because it's a little bit simpler, okay? So we are going to go ahead and use our same volume formula, which was V equals 4/3 pi r cubed, okay? And that would be for a full sphere. Now we only need to fill up half of it. So we're going to take all of this and divide it by 2, okay? So I like to save that divided by 2 step for very last. Let's go ahead and solve the top. And to do that, we need to substitute that r in. So I have 4/3 pi 4 cubed. Then I got to remember I'm going to divide all of that by 2. This will be 4/3 pi times 64 all over 2. Okay. Remember, I can take that 64 and I'm going to multiply it by the top number, which is 4, and then divide it by the bottom number, which is 3. And I'm going to have a decimal in this case. Okay. So I'm going to go ahead and round this one to the nearest tenth as well. So 85.3 pi over 2. Okay. Type in 85.3 pi. And then I'm going to take whatever that answer is, and I'm just going to hit divided by 2. Okay? Remember, if you're using that Desmos calculator, you might have to click that previous answer button in order to divide it by 2. Okay. I got 133.98. Looking to see how I round, I'm looking at my 9. 8 tells me to bump it up. So, well, 9 bumps up to a 10. So when this actually rounds up, it's going to be It's actually going to bump this up to a 10, which will make this a 0, and this I have to add a 1 to. Okay, so I will have 134, and because I still need it to be to the 10th, I need to do 0.0. For volume, this is going to be meters cubed. Okay, a lot of work in that problem. Make sure you're showing all your work and you know how to find each of those steps. There's a practice problem for you to go ahead and try both a sphere and half of one. Okay, make sure you pay attention to your radius and if it is given. On to our last page of notes, I want to talk about a great circle. So we did talk about a great circle at the beginning, but I want to go ahead and explain it to you. So if I have a sphere, a great circle is going to be wherever that radius is or wherever that center is, and it's going to be that circle around it. So it's the largest circle cutting my sphere into slices. Okay, and that's going to be called a great circle, okay, because it's the greatest one, it's the biggest one. Okay, all of the other circles that we could even possibly draw, okay, around our sphere or slices that we could get, those are going to be our small circles. Okay. So when we are given the area of the great circle in terms of pi, we need to make sure we can find the radius first. So this is going to go back to the very beginning in the surface area when we also had a formula that had 4a. Okay, so we can just use that a, but when we go ahead and do our volume, we're going to need that r. So I like to find my r first. So let's go ahead and practice this. Remember, the area of a circle is my pi r squared. Okay. Well, in this case, I'm looking at the area given, and I only have a number and pi. Well, the number is going to be r squared. So if r squared equals 2,704, and then think to yourself, how do I get rid of that squared? I square root both sides. So we'll have r equals the square root of 2,704, which is going to give us 52. Okay. So that tells us that my radius is going to be 52, and in this case it's only going to be feet. Remember, we don't square a radius. Okay, so let's try this again. So I locate the number, making sure it's in terms of pi. I have 144, and I'm going to take r squared equals 144 and square root both sides. I will get r equals 12, and my units will be centimeters. Okay. This last one you might even be able to do in your head. Okay. Looking at the number, it's in terms of pi, so I'm using 25. R squared equals 25. Take the square root of both sides. R is going to be 5, and my units is inches. Okay. So we need to go ahead and use that concept as we are solving for these. Okay. So we do have a full sphere, and it looks like my great circle area is going to be 81 pi. Okay. So the first thing we should do is find our radius. Okay. So remember, r squared equals 81. We're going to take the square root of both sides, and r will be 9. Okay. Now it's no different than that previous work that we've done. Okay. So I'm going to use those formulas. I can use either the 4 pi r squared, because I have r for my surface area, or I can go ahead and use the 4a, because I know a is the area of that great circle. Well, that's going to be 81 pi. So I have 4 times 81 pi. Okay, and if you went ahead and used the r and you used the 4 pi r squared, you would have gotten the same answer. Go ahead and do 4 times 81 to get 324 pi, and then we can go ahead and do 324 times pi, which will give me 1017.87. Make sure you're rounding it. Looking at the 87 tells me to bump it up. So my surface area for this sphere will be 1017.9 And my units was inches, and since it's surface area, it will be squared. Okay, so when we are given the area of that gray circle, it does cut down our surface area work a little bit, but we did need to find that radius so that we could find our volume as well. So let's go ahead and work on our volume formula. It was volume equals 4/3 pi r cubed. Okay, and again, we're going to substitute that 9 in for that r. 4/3 pi 9 cubed. Go ahead and do 9 to the third power first to get 729. I'm going to do 729 times 4 and divided by 3 to get 972. And I never typed in that pi, so keep that pi symbol there. This would be in terms of pi, but I want to go one step further and round to the nearest tenth. So I'm going to do 972 times pi to get 3053.63. Oh, 62, sorry. Okay, looking to see how I round, look at my 6. 2 tells me to stay. So my volume will be 3053.6. Again, I'm working with inches, and since it's volume, it will be cubed. Okay, so you do have another problem to try. Go through these steps, make sure you're practicing. Make sure you are practicing with your calculator. Okay, you see that your student practice has answers given to you. Keep in mind, depending on how you are typing this in, it might be rounded differently.